Yahoo! My name is Kendrick.
And my name is Ziya.
And we are the Android development team. Just like in Mario Kart, our Android app is the controller that drives the action. Our tablet interface is designed like a game console. Simple, intuitive, and all things Nintendo.
All of this runs over a seamless Bluetooth connection, ensuring that the car responds instantly. No delays, no drop connection.
Players can then drag and drop obstacle features, just like placing banana peels or shells on the track. Obstacles can even be placed using an X and Y coordinate input along with the direction of the obstacles.
Tapping on the obstacles changes the phase as well. These obstacles are sent seamlessly to the RaspberryPi and the card updates the path in real time during tasks.
The control wheel lets you steer the robot car, just like you'd control your kart in the race. With one smooth motion, you can navigate every feature without lag. Mamma mia!
Hello, it's me, Rishi, the race algorithm engineer behind our kart's pathfinding algorithm. I first started with calculating the shortest routes between the optimal target points and then applied obstacle avoidance. However, this didn't always work because sometimes all the generated paths had collisions. So I powered up to an A-star algorithm where I used 6 possible next steps to generate the path. Here, obstacle avoidance was integrated into the pathfinding and our kart finally managed to find paths without collision. Once all paths were mapped, I applied the traveling salesman problem and calculated the least cost Hamiltonian path. This simulation shows the step-by-step controls with full path animations of the entire traversal. Our kart was also implemented with API communication, so whenever we reached an obstacle, we immediately sent the next movement command to the kart while processing the image in parallel.
Now image recognition. Our role is spotting obstacles on the track, just like identifying bananas in Mario Kart. We use YOLO V12, trained on over 23,000 images with RoboFlow. This gave us a lightweight yet powerful model perfect for real-time detection. The RaspberryPi sends images along with snap commands to our laptop, which runs the inference and returns the target. At the same time, the annotated image is saved locally for review. This way, our kart can see obstacles ahead and react instantly, making the race both smarter and safer.
Let's go! For our project, the RaspberryPi acts as the race coordinator, bridging the Android tablet and the STM hardware to keep every part of our kart in perfect sync.
For task 1, the RPi captures a snapshot of the track and automatically connects through our RPi bridge, linking the Android controller and STM.
The RPi sends that image to the algorithm client, which retrieves it from a shared folder, runs YOLO 12, and sends the identified image back.
If multiple items appear, our system returns the ID of the largest bounding box, the biggest obstacle in the track.
We use sequential operations to keep the race smooth. First, we capture the process, we return, and then we ensure there's no lag in communication.
For task 2, when we detect an obstacle, we snap an image, letting our kart recognize the directional arrows. This upgrade helps us streamline the communication between the RPi and STM, giving us that turbo boost effect.
We also added a thread in the algorithm client, keeping the communication loop open so nothing blocks made race.
Here we go! I'm Clint, I'm Yushan, and the mechanics behind our kart working on the STM32 microcontroller and hardware systems to keep our racer accurate and precise on the track. Our kart runs on 2 DC motors for power and a servo motor for steering, letting it handle sharp turns and drifts.
So we equip the motor with a 9-axis ICM20948 module and utilize the gyroscope to help us make precise turns at any angle. Up front, we've got that ultrasonic sensor acting like a red shell radar to spot obstacles and stop safely. On the sides, infrared sensors work like green shells, detecting nearby walls or hazards so the kart can avoid damage.
So with these systems combined, our kart can race smoothly, dodge obstacles, and stay on track. Here's a compilation of our preparation for the race, and we hope you enjoy it.